Okay, so after this very basic first example, let us take a little complicated example with more number of loops in that. That is the second number. It is very important because in this example there is a very special feature. So previous numerical, what we had found was the forward path was touching both the loops that was there in the diagram. But in this case we are finding that there are four loops. Eventually I'll explain, and one loop is not touched by the forward path. Then there comes that pk delta k term in the, as you have found in case of Mason's gain formula. So previous example, whatever you have found, delta k term was not there. Okay. So in previous example, there was two forward paths. So it was P1 and P2. How to find delta k and what is actually delta k? So delta k is a thing which is actually found out when a forward path is there and a loop is there, and one loop and forward path, they are not touching each other. In that case, that term specifically delta k arrives. Now in this case we are finding that is there is only one forward path. So question is the same. We are supposed to find CS by RS. So in this case we are finding there is only one forward path, that is G1, G2, G3, G4, G5. So there is only one forward path you can find out present in this case. That means there can be maximum delta 1. So only one delta k can be there in the numerator. So you have to follow the Mason's gain formula thoroughly. So below there is the, so Mason's gain formula is done to find out what is the transfer function of the given signal flow graph. So here you are finding that in the forward path there are 5 nodes. Okay, and these 5 nodes are common to there are loops. So this is the first loop you are finding, this first loop which is having the loop gain as minus G2 H1. G2 is the forward path and H1 is the feedback path with negative feedback. So L1 is equal to minus G2 H1. L2 is equal to minus G4 H2. So it is written here minus G4 H2. Then this is the third loop. Okay, and in previous day we had found was that in book this direction of minus h3 was given wrong. Okay, so actually h3 is feedback, and in this case the forward path is having g7 from right to left, and in that case feedback path is having minus h3. So minus stands for it's a negative feedback, and h3 is the feedback coefficient. So this is the feedback path which is from left to right. So far we have seen all the feedbacks going from right to left, because right side there is the output. So this is not a feedback from the output. Okay, so this is a very special case. So in this case the forward path is G7 and the feedback path is minus H3 and is a negative feedback. So this is another loop. Okay, so what is the definition of loop? Starting point and end point is same. So if you are starting from this node, then you are going from right to left, again you are coming back from left to right, and starting point and end point they are same. That's why this is called as loop 3. So in this case the feedback path is minus G7H3. So these are three small loops, and you find that this loop 1, loop 2 and loop 3, they are called as non-touching loops. So in this is another special case, because in this case you will be finding that there are three loops which are non-touching. Okay, so this is for the first time you are seeing this kind of case. In the previous example you found there were two loops which are non-touching. So there was coming another separate term in that case where we were multiplying the gain of loop 1 and loop 2. So in this case we will be finding that this L1 and L2 their gain will be multiplied, because that is the term where first we are trying to find out the pair of loop which are non-touching. Okay, so in this case this loop 1 having these two nodes and loop 2 having these two nodes. So there is no common node between loop 1 and loop 2. Hence loop 1 and loop 2 is non-touching. Loop 2 and loop 3 is non-touching because they are not sharing any common node. And again loop 1 and loop 3 is non-touching. So there are three pairs of non-touching loops. So that is the actually count of pair of non-touching loops. So there are three pairs of non-touching loops. Their gain has to be multiplied. I will show you in the step 3. So step 1 is for finding the forward path gain, that is G1, G2, G3, G4, G5. There is only one forward path. Step 2 is for finding individual loop gains. So we are finding there are 4 L1, L2, L3, L4, and their gain is given. And fourth loop you are finding that G2, G3, G4, G5, G6, G7, G8. So this is G2, G3, G4, G5, G6, G7, G8. It's a very big loop, and this loop 4 actually is touching all the loops. Okay, this is the common part. So G2 is the common part between loop 1 and loop 4. G4 is the common part between loop 2 and loop 4. Okay, and G7 is the common part between loop 3 and loop 4. So what we are finding is loop 4 is touching all the other three loops. Okay, so this is one thing we are finding, and one more thing we are finding, that here G6, G7, G8, they are fed back, and all this loop is actually is uh, a positive feedback loop. Okay, because there is no negative here. Okay, so L3, L2, L1, they are all having negatives, but this L4, this is not having any negative. So as this is not having any negative here in the transfer function, this part will become negative, because while finding the denominator, it is 1 delta. Whenever we find delta is equal to 1 minus of individual loop gains, so it will be 1 minus of minus G2H1, that means it will become 1 plus G2H1 plus G4H2 plus G7H3, and this will be minus. Okay, this will be minus G2, G3, G4, G5, G6, G7, G8. So this is something you have to observe, understand, and be careful from the beginning. So in denominator, at least one negative term we will find, and that will happen because of this L4. Okay, now next step, we are finding the loop gains of a pair of non-touching loops. So you are finding that L1 and L2, they are non-touching, so multiply their gain. This is G2, G4, H1, H2. So here we find G2, G4, H1, H2. Then L1 and L3, they are non-touching, so it will be G2, G7, H1, H3. We are finding here G2, G7, H1, H3. The negatives are multiplied, they are becoming positive. And then loop 2 and loop 3. Okay, if you multiply them, it will become G4, G7, H2, H3. So G4, G7, H2, H3. So these are three pairs of non-touching loop. When do we call two loops are non-touching? If they are not sharing a common node. Okay, likewise. So these things were common in previous numerical. Also, we had found that there was one pair of non-touching loop. In this case, there is only three pair of non-touching loop. Okay, so but there is nothing new in this case. Now in next slide, what you find is whatever will come, it will be a new thing. What is the new thing? Step 4, there is a combination of three non-touching loops. Okay, so this is a new thing we are finding. Three non-touching loop is loop 1, loop 2, and loop 3. Okay, so there's a combination of three non-touching loop in the system L1, L2, and L3. They are non-touching, so multiply their gain. So L1 into L2 into L3. So here both all the things are minus, so it will be minus, minus, minus. So everything will become minus, and then G2, G4, G7, and H1, H2, H3. Okay. So you should be observant enough. So this SFG signal flow graph is only asking for your good observation. And L4 does not come anywhere because L4 is touching all the loops. So in the pair of non-touching loop, in the three non-touching loop, nowhere the L4 comes, because it is touching everything, even if it is touching the forward path as well. So up till this, there was no doubt. Fifth step is finding the denominator. This part is also easy. This is delta. Okay, so there are two different things. One is delta. Delta is the denominator. What is that? 1 minus addition of all the individual loop gains. That is the first loop. So here instead of L1 you will write minus G2H1. In case of L2 you will write minus G4H2. In case of L3 you will write minus G7H3. In case of L4 we will write G2, G3, G4, G5, G6, G7, G8. So this part only will be positive, and all other parts will be negative. Okay, plus L2 into L1. That means multiplication of these two loop gains. L1, L3 multiplication of loop 1, loop 3 gain, and L2, L3, that is multiplication of these two loop 3 gains. Minus. So this minus, this plus, this minus, they are from the formula. And inside bracket, whatever comes, that depends on what the value is given in the numerical. So 1 minus of single number things are coming minus, and even number things are coming plus. What is meant by odd number? Individual loop gains. Okay, this is three non-touching loop gains, then five non-touching loop gains, all will be negative. Then two non-touching loop gains, it will be positive. Four non-touching loop gains, that will be positive. Likewise, this formula continues. But as this system is smaller enough, so only up to three non-touching loops we are finding, and fourth loop is touching all. So now first see, so this is how the delta is found. So while doing the final transfer function denominator, we will substitute all the values of g and h here, and we will find, and I'll show you what is the actual delta. Now, the most important thing and the part which students don't understand. Okay, so in Mason's gun formula, whatever we found was numerator was summation of pk delta k. So in this case, pk is nothing but g1, g2, g3, g4, g5. That is the forward path gain. And as there is only one forward path, so only it will be p1. Okay. Now the difficult is what is delta 1? Okay, so delta k, and as k is equal to 1, k is the number of forward paths. So in this case, k is equal to 1. So concentrate, this is the most important thing which generally students don't understand, and there they make mistakes. So numerator, generally student makes mistake. Denominator, most of the students, 80% of the students write denominator perfectly, but 20% of the student write only numerator perfectly. Okay, so be careful. So what is 1 minus L1 plus L2 plus L3 plus L4 plus L1 L2 L2 L3 L1 L3 L1 L2 L3? This is the formula. Now we are supposed to see that this forward path is touching which loops. So we are supposed to write numerator as pk delta k. Pk we have found out g1, g2, g3, g4, g5. Now delta k, how to find that? So for delta k, write the equation of delta first. And we know what is L1. What is L1? Minus g2h1. What is L2? Minus g4h2. What is L3? Minus g7h3. What is L4? We know it. Okay, likewise, so all the L values we know. Okay, now first we have to do some elimination. What to eliminate? First, we have to check in the given delta. So what is actually the denominator? All the Lx is equal to 0, which are touched by the forward path. So forward path P1, what is the gain of that? G1, G2, G3, G4, G5. This is touching which all loops. So this forward path is touching loop 1. So wherever L1 is there, we have to make that 0 in this delta equation. Then we will find what is delta k. Then this forward path is touching loop 2. So wherever L2 is there, we have to make it 0. That means all this minus G4H2 wherever is there, we have to make it 0. Why? The reason being the forward path is touching this loop 2. Then loop 4 wherever is there. So this is L4, L4 wherever is there, L1, L2 and L4. All those things will be made is equal to 0. And only L3 will be L3. So what is the value of L3? Minus G7H3. So in this equation delta k, how to find the equation of delta k? Only the L3 things will be non-zero. That is minus G7H3. Wherever else L1, L2, L4 are there, they will be 0. The reason being L1, L2, L4 are being touched by the forward path P1. So in that case, you have to substitute. So L1, L2, L4 touched by the forward path P1, and hence they are is equal to 0. So only L3 is non-zero. So if there are two forward paths, then for both the forward paths you have to do this thing separately. So in that case delta 1 will come, and in that case delta 2 will come. So P1 multiplied by delta 1, P2 multiplied by delta 2, an addition of this thing. So what will be the numerator if there are two loops? There are two forward paths, not loops. If there are two forward paths, it will be P1 delta 1 plus P2 delta 2. So in this case, as there is only one, so P1 value is G1, G2, G3, G4, G5, and delta 1. How can I find delta 1? Write the equation of delta, and there wherever L1, L2, L4 are there, make it equal to 0. So now see what it becomes. So delta k is equal to delta 1, and that will be only the numerator pk into delta k, p1 into delta 1. How to find delta 1? 1 minus L1 0, L2 0, L3 is L3, L4 is 0, and L1 L2 both are 0, so it is 0. L1 L3 0 into L3 it will be 0, L2 L3 0 into L3 it will be 0, and here L1 L2 are 0, so this term will go to 0. So only what will remain is 1 minus L3. And what is L3? G7H3. So what is the delta K value? 1 plus G7H3. This is the most important thing which I wanted to teach you, and after this there is no other new concepts which I can teach. So if you understand this numerical, you are through with all the concepts. Now it is only practice, and bigger numerical with two non-touching loops, maybe three non-touching loops, maybe four non-touching loops, that we will solve. So there are no new fundamentals in this case. So what is now numerator? So denominator I had shown you in the previous page, or here also you can find what is the denominator. So if you just ignore k, what is delta? Delta is equal to all these things. Okay, substitute all the loop values L1, L2, L3, L4, L5, L4, and you will find what is delta. And that is denominator. What is numerator? Pk into delta k. That is, as there is only one forward path, it is P1 into delta 1. P1 is G1, G2, G3, G4, G5. ये भी स्टूडेंट लोग बहुत अच्छे से समझते हैं. What they don't understand is how to find what is delta k, what is delta 1. So what is the process? First find what is the denominator equation, and there with respect to one loop you have to find if the loop is touched by the forward path, then that loop has to be made equal to 0. So as in this case, loop 1, loop 2 and loop 4 are touched by the forward path P1. Hence in this delta equation, wherever L1, L2, L4 are there, I have to substitute that by 0, and wherever L3 is there I have to write there minus G7H3, and that has given me the delta k value as 1 plus G7H3. So what will be the numerator? Numerator will be as given below. P1 delta 1 is equal to G1, G2, G3, G4, G5 multiplied by 1 plus G7H3. So this first part is the P1 or Pk, second part is the delta 1 or delta k. Now let us see what is the overall transfer function. So now numerator and denominator, you cannot write, you cannot leave it in terms of L. You have to substitute all these G and H values. In some numerical, instead of G and H, I can give you values directly. So I can give you the value of 2, 3, 7, 9, 10, any values, or fraction also I can give. So the gain values, I can give you some integer values or fraction values or something. So either there are two ways. Either you can solve, you can give name to it. Suppose if I give here, instead of G2 I said 2. Okay, instead of G3 I said 7. Instead of G4 I said is 11. Likewise. So you can, in that case, you can give the name. So this is G2, this is G3, this is G4 and all, and you find out what is the transfer function with G and H, and finally you can substitute what is the value of G and H. So be careful, this kind of question will be asked, and instead of G and H I can give directly some values. Okay, so either you give a name, find the transfer function in terms of G and H, substitute the values, or directly you can substitute the integer or real values and you can calculate how much is going to be the transfer function. So in that case the transfer function C by R also will become like a figure. So one numerical will solve like that. Now the last step, we have shown all the loops for your understanding. Now this is what is called as transfer function CS by RS. Now as there is only one forward path, it is P1 delta 1. So this is P1, that is nothing but the gain of the forward path multiplication of that. And what is delta 1? Delta 1 is that value of delta k, or that value of delta which part is not touched by the forward path P1. So what we found was only the loop 3, it was not touched by the forward path. And the caution is, if there are two loops here, okay, which are not touched by the forward path, in that case the second term also will come. Suppose there is another loop here which is not touched by the forward path, so 1 plus G7H3 plus that loop. And if those two loops which are not touched by the forward path, if those two loops are again non-touching, so plus of their multiplication, so all these things again will come. So numerator defining becomes difficult, so most of the people makes mistake in the numerator only. Okay, so denominator most of the people write properly. So this is what it is: G1, G2, G3, G4, G5. This is the P1, this is delta 1. Now this line you should write first. So 1 minus individual loop gains. So this is loop 1 gain G2H1 negative, loop 2 gain G4H2, loop 3 gain G7H3. Then there is a negative because G3 is negative, G4 is negative, G7H3. But the fourth thing is positive, because this is G6, G7, G8, this is a positive feedback. Likewise, plus this is L1, L2, this is L1, L3, and this is L2, L3. So as all these loops are negative, whenever two loops are multiplied, it becomes positive. Minus, so this is the minus of the formula, and multiplication of L1, L2, and L3 gain. As all are negative, this is negative. So in the final line, all the negatives become positive and all the positive becomes negative. This is what we are finding. So 1 plus L1, okay, plus L2 plus L3 minus L4. Okay, because L4 we are finding that L4 was positive feedback, hence this is minus, plus L1 L2 whatever are the gain, plus L1 L3 plus L2 L3, and this was minus of minus, hence this becomes plus. So this is the transfer function of the overall system. In numerator we find there is only one P1 multiplied by delta delta at delta k, that is delta 1. So there are two terms in the numerator, and there are around 8 terms or 9 terms in the denominator. So this is quite a complex numerical. There are 2 terms in the numerator and 9 terms in the denominator. So with this, the first session or first lecture on signal flow graph, it finishes. Thank you.